about the second application of resonance, that is plus n and minus m, that is mesomeric effect, or plus m, or we're going to talk about first plus r, electron donating. So first of all, these are two effects, plus m and minus m effect. On that we're going to talk about very first effect, that is plus m, or we can say minus r. Plus m stands for mesomeric effect, r stands for resonance effect. So what is the plus m or plus r effect? Let's say we have alcohol, phenol over here. Now what happens? We have seen the conjugation. There is a double bond in the conjugation with lone pair. This will donate electron and electron will shift on this direction. So it will form like this, bond like this, and the resonance will keep on going. Negative over here, double bond OH positive, and the resonance will go again over here. And when the resonance will go over here, so it will be having negative charge over here and double bond OH plus. Now the negative charge of resonance shifts on these three directions. What actually happening? If I talk about particularly this group is donating electron to the phenol, the benzene ring, right? So this particular group is donating. So whatever electron donating group we have, it's showing plus m effect. It is showing plus m effect, mesomeric effect, mesomeric plus m. When it has tendency to pull the electron, it would show minus m, but right now it is showing plus m. So what are the groups which show plus m effect? So first of all, it increases electron density in benzene ring. It increases electron density in benzene ring. So what are the examples of the group? First, like we have any halide, then OH alcohol, NH2. Whenever we have a lone pair right next to the double bond, then it will be having plus m effect. SH, S, CH3, right? If I ask you, does CH3 show any plus m effect? No, it won't show any plus m effect because doesn't any conjugation. But when I talk about CH2 minus, yes, it will show. When I talk about CH2 plus, it won't. When I talk about F, when I talk about Cl, when I talk about Vr, yeah, it will show. When I talk about I, yes, it will show. OC double bond OCH3, yes, it will show. And if I talk about the compound NRR, yes, it will show. When I talk about NH, C double bond OCH3, yes. So these all will show plus M effect. Actually, this will not show, that we have mentioned. Plus, but these all will show plus M effect because they have a tendency to donate the electron pair towards the benzene ring. If I take the example of this, so this is a tendency to donate the electron. So this type of group will show plus M effect. Now what about the second effect, that is minus M effect? Minus M or minus R, or we can talk it as an electron withdrawing effect. It has a tendency to withdraw the electron, so it is electron withdrawing group effect. X double bond Y. When we have like bond like X double bond Y directly connect with the phenyl ring, when electronegativity of Y is greater than X, in that case there will be a minus M effect, or we have a X which has an empty orbital, then it has a tendency to pull the electron. For an example, let's talk about the nitrobenzene and double bond O. So it will pull the electron, it will give it here. So what will happen? It is positive charge double bond O and O and O. And it will give the electron here N. Positive double bond N O and O. It will give the electron over here. Double bond N O negative and O. And it will give the electron over here. Now whenever electron is given by like that NO2, so there is a generation of positive charge, right? Now finally it will go like this. And double bond O and O. Then these all will show minus I effect, minus M effect. In this all there is a tendency to pull the electron. It will decrease the electron density in benzene ring. It will decrease the electron density in the benzene ring. Now, what are the other type of compound which will show minus I effect? NO2, aldehyde, acid. When it has a tendency X double bond Y, and it has a tendency to get the electron X double bond Y, when it has tendency to get the electron from the electron rich species like benzene or alkene. So when Y have more electronegativity as compared to X, so it will show like this. So C double bond OH and CCl3, C double bond OCl. Does CCl3 will show or not? Tell me. Yeah, it won't show because it don't have any lone pair and it doesn't have that X double bond Y type of group. C double bond O NH PH, C triple bond and cyanide, CH2 plus and BH2. These all will show minus M effect. So what is a mesomeric effect? Now when I talk about mesomeric effect, it has two times plus M or plus R, and it has minus M or minus R. We have seen all the examples, but remember, we have studied till two groups, resonance and inductive. Let's talk about some examples. When I talk about phenol, we know phenol has a tendency to donate the electron plus M, and it has also tendency to pull the electron through the minus I. If I talk about other example, like this compound, halobenzene, or I talk about like NHC double bond OCH3. If I talk about like halogen, it has tendency to donate the electron and pull the electron as well. It has tendency to donate the electron and pull the electron as well. So which, or if I draw some more example like C double bond O, this type of ester, so it has donate the tendency to pull the electron, negative I also. So we will answer the question according to what effect. Plus M minus I means mesomeric or inductive. So remember, always R has a greater tendency than I, because R there is a permanent shifting, right? Permanent, but I have the partial shifting of electron. Not permanent shifting, we can say the whole shift of electron. There is a complete transfer of electron, but I has a partial transfer of electron. So resonance effect is more dominating than inductive effect. So whenever there is a, like here, what should we consider? Plus M or minus M? We will consider plus M. Plus M. Remember, in case of halogen, we consider minus I. Remember, it is very important. Halogens has minus I greater than plus M. Only in case of halogen there is an exception. Now, we have two or three other non-generalized cases we will say there. One of them is halogen. So in case of halogen, minus I dominates over plus M. Now plus M and minus I will dominate plus M. Minus M and minus I will dominate minus M. So mesomeric is always dominating over minus I. Now let's talk about some example. Compare the electron density in benzene ring. Let's solve some problem. Compare the electron density in benzene ring. First, we have an example like this: toluene, phenol, chlorobenzene, nitrobenzene. Second, we have an example of this compound and this. Third, we have question of cyanide, CH3, NH2. Fourth, we have ester, amine, phenol. So now you have to compare the electron density in the benzene ring. Now just pause the video and try to answer by your own how you can guess the electron density in the benzene ring. So now let's talk about the effects. The CH3 has plus I effect. The phenol has plus M effect dominating. Chlorine has minus M dominating over plus M. And the nitrobenzene is minus M. So plus M in electron density increase. So this will be first. And then plus I comes second. Then minus I comes third. Then it is fourth. Now in these two it is showing plus M and it is showing minus M. So plus M is dominating. So it is more electron density than 1 and it is 2. NH2 has plus M, CH3 has plus I, cyanide has minus M. So it is first it is increasing, it is lesser electron and it is withdrawing effect. Third. This is minus M, this is plus M and this is also plus M. So here we have contradiction of two plus M groups. Plus M of amine as aniline and plus M of phenol also. So what happens? Aniline and phenol. The phenol has if you talk about the electronegativity, F, O, N and Cl. These are the top 4 electronegative elements over the whole periodic table. So oxygen is more electronegative as compared to nitrogen. So oxygen has a more tendency to keep the hold of electron. Oxygen has more hold of the electron as compared to nitrogen. So it has more plus M, right? So it is first, it is second, it is third. So oxygen has a more tendency to less tendency to give. So it is lesser than NH2. Now let's talk about some other compound which we call adjustive. Adjectives are the compound which have both the tendency of plus M and minus M, like NO group, nitroso group. If we talk about nitroso group and double bond, nitrogen has a lone pair, so it has tendency to plus M effect as well, but and double bond O, it has tendency to pull the electron over here, so it is minus M. Then it is vinyl group also, CH2 double bond CH. Vinyl group also then it has also tendency to pull the electron and it has also tendency to push the electron. So push the electron and pull the electron, both the tendency. So what we will show that whether it will show plus M or minus M. So that this vinyl group has both the tendency plus M and minus M, but here minus M dominates over plus M. You have to remember that case. Remember that nitroso group has minus M dominates over plus M. So whenever it is asked what is the final effect of NO2, we will be talking about the minus M effect. But there are some compound also like O negative, CH double bond CH2. In that case, it is showing plus minus M because it has a tendency to pull the electron. If we talk about CH2 plus and this benzene, so when benzene we are talking about, it has here plus M. When CH2 talking about, it has here minus M. So whenever the group is not mentioned, it is a relative term. Plus M and minus M is a relative term. Right? The NH2 we have, and we have phenyl ring. So it has a plus M effect and it has tendency of minus M effect. So again, plus M and minus M is generalized and relative term. If we have mentioned any group with respect to benzene, we will talking about that group. But if we have mentioned that which effect we can see over this compound like, so it has both the tendency plus M and minus M effect because it is plus M group and it is minus M. But if we talk about group only, then vinyl group and nitroso group has the both tendency to pull the electron through the mesomeric and push the electron through the mesomeric. But in case of nitroso, the plus minus M dominates. It is practically seen that minus M dominates over plus M.